Okay guys, so we're going to continue on with 20.1, except now we're looking at the explain one, which is using zeros to solve quadratic equations graphically. So we're going to be working with page 938 and 939, so make sure that you have those pages. So a zero of a function is an x value that makes the value of the function 0. The zeros of a function are the x-intercepts of the graph of the function. A quadratic function may have 1, 2, or no zeros. Quadratic equations can be solved by graphing the related function of the equation. To write the related function, rewrite the quadratic equation so that it equals 0 on one side. So all we're doing is replacing the 0 with y. So graph the related function, find the x-intercepts of the graph, which are the zeros of the function. The zeros of the function are the solutions to the original equation. And so for part A, the first thing that we need to do is set it equal to 0, and so we need to move this 3. And so the opposite of a negative 3 is a positive 3. And so I should get 2x squared minus 2 equals 0. Let's double check that, and that is what they have. So now if we plug in 0 for x, because we're looking at our table here, so we're going to plug all these points in here for x, we have, and I'm going to start up here for more space, we have 2 times x squared minus 2 equals 0. We have 2 times x squared minus 2 equals 0. 2 times x squared minus 2 equals 0. 2 times x squared minus 2 equals 0. 2 times, not x, but it is x squared minus 2 equals 0. And so what I'm going to do is I'm going to plug in each one of these points. And so my first point is going to be negative 2. My second point is going to be negative 1. My third point is going to be 0. My fourth is 1. And my fifth is 2. And so if I solve these, I have negative 2 squared, which gives me a positive 4, times 2 minus 2 equals 0 is going to be 8 minus 2, so 6. So I should get a 6, which I do. If I plug in negative 1 in, I have 2 minus 2 equals 0. Again, it equals 0. 0 squared gives me 0, and anything times 0 is 0. So we get a negative 2. If I plug in 1, I have 2 times 1 minus 2, which again gives me a 0. If you guys notice, we have 0, 0. Well, that actually makes sense because it's quadratic and it's symmetrical, right? When we graph any quadratic function, we know that it will be symmetrical. And so when I plug in this last 2 here, I get 4. I have 2 times 4 minus 2. Well, again, that's going to give me 6, which makes sense. It's symmetrical. And so I'm going to graph the points represented by the table and connect the points. And so I would start by graphing 0 and negative 2, which is going to be here. It's also going to be my axis of symmetry, x equals 0. I'm going to plot 1 and 0, so I would go here. And then I know I'm going to have to plot negative 1 and 0. Negative 2 and 6, and what's symmetrical? Well, 2 and 6. And so if I connect those, I get a nice graph. So the zeros of the function are negative 1 and 1. Okay, so we have negative 1 and 1. So the solutions of the equation 2x squared minus 5 equals negative 3 are x equals negative 1 and x equals 1. Okay, so let's practice that a little bit. So I want you guys to go ahead and do B with me. And so if I'm looking at B, I can see that we have 6x plus 8 equals negative x. And so I'm going to add that x squared to the other side. And so that cancels, but I have x squared plus 6x plus 8 equals 0. The related function is 0 equals x squared plus 6x plus 8. And so if I plug in the values given for x, I'm going to plug those into this new equation. And so I have 0 equals x squared plus 6 times x, I'm not going to fill in the x, plus 8. And if I go ahead and put in my negative 5 here, I'm going to say negative 5 squared plus 6 times negative 5 plus 8 gives me 25 minus 30 plus 8. And so I get negative 5 plus 8, which will give me a positive 3. And so I'm going to go ahead and graph that. So I have a negative 5 about here, and I'm going to go up to 3, which is about here. So I'm going to go ahead and plug my next point in, which is negative 4. So I have 0 equals x squared plus 6 times x plus 8. Well, again, I'm plugging in that negative 4. And so I have 16 minus 24 plus 8. Well, I know that 16 and 8 are going to give me 24. So I have 24 minus 24, which is 0. So I will have a 0 here. So I know that because this is quadratic and it is symmetrical, I will also have a 0 and a 3 here. We'll do that just so you can see it, but I want you guys to understand that because it's symmetrical, these points will have the same y value. Okay, so now if I plug in, or well, if I go ahead and graph that, I have negative 4, 0. And I have negative 2, 0. I also have negative 1, 3. So I'm going to go to negative 1 and I'm going to go up to 3. And I'm going to plug in my negative 3. And so I'm going to say 0 equals x squared plus 6 times x plus 8. I'm going to plug in my negative 3. So negative 3 squared plus 6 times negative 3 plus 8. And so I have 9 minus 18 plus 8. So I have 17 minus 18, which is going to give me a negative 1. And so I have negative 1. And if I go to negative 3 and I go to negative 1, my point's going to be about there. And so if I connect those points, I'm going to get a graph like that. My axis of symmetry is going to be at negative 3, so x equals negative 3, which is right here. And my zeros are going to be at negative 4. So the zeros of the function are negative 4 and negative 2. So the solutions of 6x plus 8 equals negative x squared are x equals negative 4 and x equals negative 2. Okay, and so we're going to continue on. So how would the graph of a quadratic equation look if the equation has 1, 0? Well, if the equation has 1, 0, what do you guys think? The graph will intersect. I wish I could spell intersect. Sorry about that. The x-axis at its vertex. Okay, so make sure you guys get that written down. And then we're going to go ahead and look at number 3. Okay, so let's go ahead and look at number 3 together. Everybody needs to write this. And so we have x squared minus 4 equals a negative 3. Well, the first thing that we need to do is add that 3 to the other side and set this equal to 0. And so we have x squared minus 1 equals 0. The next thing I'm going to do is create a t-chart. And I'm going to work with negative 2, negative 1, 0, 1, 2. And if I plug those points into x, I have x squared minus 1 equals 0. And I'm going to start with negative 2. So I have negative 2 squared, which gives me 4 minus 1 equals 0. So 3. So I have 3 here. I'm going to go ahead and do that for -1, and so I have x squared minus 1 equals 0. If I plug in my -1, I have 1 minus 1, which equals 0. If I plug 0 in, I have x squared minus 1 equals 0. Again, plugging in 0. Well, 0 squared is 0 minus 1, so that's going to give me a -1. I'm going to continue to do that, even though these points should be the same because they're symmetrical. Let's just go ahead and double check with 1. And so I have x squared minus 1 equals 0. Well, if I plug in 1, well, 1 squared is 1 minus 1 equals 0. And so I have 0 here. So I know that I will have 3 here. And so I'm going to go ahead and plot this point first. And I'm going to start with, let's use a different color. So we're going to plot this. So we're going to go to -2 and +3. If I do that, I can go to 2, +3. So I'm going to go to 2, +3. Okay, I'm going to go ahead and plot my -1 and 1 next. And so I have -1 about here, 1 about here. And those are going to be -1, 0, 1, 0. And my vertex is actually going to be 0, -1. And so I'm going to have a point about here. So x is going to be 0. That's my axis of symmetry, right? If I draw that line, I'm hitting x equals 0. Now I'm going to go ahead and I'm going to connect my points here, make a U. And I notice that I have 2 zeros. And so my zeros are going to be the zeros of the function are -1 and 1. So the solution, or solutions, because we have 2 zeros, of the equation are x equals -1 and x equals 1. Okay, that would be how you would write your answer.